A car engine is basically an internal combustion engine where power is generated through expansion of high temperature and high pressure gases. A lot of heat generated due to the combustion gas and the friction of the mechanical parts. For sustained operation, this excess heat should be removed from the engine and kept at operating temperature. These are the parts of cooling system. First, we have the water pump. The water pump is the heart of the cooling system. It is responsible for pumping the coolant. Next is radiator. Radiator is the heat exchanger used to transfer the excess heat developed by the engine to the atmosphere. Next is thermostat. Is a valve that regulates the flow of the coolant and help to maintain the temperature of the engine. Next is coolant temperature sensor. The coolant temperature sensor is used to monitor the engine's temperature. And lastly is the coolant. The coolant is the chemical used in the cooling system. Let's start for the operation. When the engine is cold, the bypass valve stays open, so the coolant bypasses the radiator and recirculates to the engine. This helps the engine to heat up to operating temperature quickly. Eventually, the coolant temperature increases by absorbing the heat from the engine. Once the coolant starts to reach higher temperature, which usually between 160 to 190 Fahrenheit, the bypass valve will start to close and the main valve will start to open. This allows the cold coolant from radiator flow to the engine side and the hot coolant from engine side to the radiator. Most cars, the coolant temperature sensor is located near the thermostat housing. It will turn on the radiator fan if the coolant to the radiator side is high temperature. Now the hot coolant in the radiator will release its heat to the atmosphere with the help of the fan. At the same time, the cold coolant received from the radiator will start to absorb the heat from the engine or the next heating liquid inside. A closed system always builds up pressure. So how to maintain the pressure? Here comes the role of the radiator pressure cap. It consists of a spring-loaded valve mechanism which will respond to higher pressure. Reaching a pressure above 15 psi will push the pressure cap valve and the coolant flows to the expansion tank while the pressure goes down and the operation level. And when the system cools down, the vacuum inside the system sucks back the coolant from the expansion tank. In case if there is too much pressure built up in the system due to trapped air or other failure, the coolant in the expansion tank will be pushed out through the overflow hose.